Good afternoon. So today we will have a look on the video codec landscape. But let's start with a joke because things then will get more technical. So the current situation is there are 14 competing standards. So people say, oh, it's ridiculous. We need to develop just one universal standard that covers everyone use cases. So the next situation is there are 15 competing standards. And that means that it seems that, standards spring up like mushrooms. And this is, I think, in my opinion, a good snapshot of the video codec landscape. By the way, today we will speak about 3 standard organizations working on video coding. MPEG and ITU have been working together to develop video coding standards for a long time. They have developed many generations of video codec. Then recently, the Alliance for Open Media has been formed. I mean, not so recently, they've been working for 7 years on their codec called AV1, and that it's a royalty-free codec. And there is also MPI, the moving picture audio and data coding by artificial intelligence. It's a newborn international group. It has started activities in 2020, and it has AI as its core technology. As you probably know, MPEG has been recently reorganized, but I have to admit that there is little change in how MPEG standardization operates. And it has a new structure made by advisory group if they are not involved in standard, and working groups if they are directly involved in producing standards. Of course, I won't go through all of them, just a few related to video. For example, the WG4, the video group in MPEG, that has produced 2 new video coding standards, the essential video coding and the low complexity enhanced video coding. The WG5, also called JVET, that has developed the current standard, the VVC, versatile video coding, and also the AG5, that is the visual quality assessment group in MPEG. So starting from MPEG 5, part 1, it is called Essential Video Coding. And if you can read the sentence in bold, it comes from MPEG documents. The goal is to provide solution to those that want to use an ISO standard but cannot use HEVC. It's an interesting use of words, and I think there is a clear reference to the patent issue that we will see later. There are companies that are interested in solutions that are less efficient compared to the state of the art, in this case to VVC, but that have other benefit, for example, in terms of a clear licensing model. This is particularly true, for example, for certain kind of markets, for example, for the video streaming. And EVC has an interesting feature because it is able to activate or switch off individually each tool. This mechanism is supported inside the bitstream, so EVC is able to remove the tools that cannot be licensed under a reasonable licensing term. It is based on technologies provided by those companies, and there is also an open source implementation, public available, provided by Samsung. There are 2 profiles in the EVC. The baseline profile that you can see in green, that is made with technologies older than 20 years, so they are royalty free. By the way, these two words, royalty and free, I think should be forbidden from the video coding world because they don't have the same meaning that you can find in the dictionary. Here, royalty free means that at the end, probably you have to pay, but we will see later. And there is also the main profile with tools designed to improve the coding efficiency, and they are not royalty free. And when turning off a tool in the main profile, there is a fallback on the baseline profile. EVC is a powerful standard from MPEG that in its baseline profile has a coding efficiency almost equal to HEVC, while in the main profile is shown the capability of reducing the bit rate by around 36%, at least for 4K HDR sequences. The other standard from MPEG, video codec standard, is MPEG 5 Part 2, called Low Complexity Enhancement Video Coding, and that aims to improve the coding efficiency with no increase in complexity by using a base bitstream plus an enhancement bitstream. And so the base bitstream can be decoded by an hardware decoder, while the enhanced bitstream can be is suitable for software processing. And it's a multi-scale codec that can wrap around different existing codec, for example, AVC or HEVC. And this tool enhance the underlying video codec with two enhancement layers. So at first, the source picture is downscaled, then it is compressed using, for example, AVC or HEVC and so on. Then it is decoded inside the encoder loop, and a residual is generated subtracting the decoded picture with the source picture and also the downsampled picture in order to get these two layers of residuals. This is the same picture, but from the point of view of the decoder. And so, as you can see, this is the decoded picture that is added with a first layer of residual, then it's upscaled, and it is added with a second layer of residuals. There is also a temporal buffer because the enhancement layer can be predicted from previously received layers, and also I think to manage the flickering effect in the video. And this is an example of enhancement layer. This is a picture from Formula One. And as you can see, there are a lot of details, a lot of edges, a lot of high frequencies that are very costly for a traditional approach, a traditional codec. So I think that the core of their algorithm is a small transform that is optimized to manage these high frequencies. VVC, the versatile video coding, it was completed in 2020. And the main target are the 360 video and the high dynamic range. It has a broad range of applicability, for example, computer-generated content, light field, depth map, point clouds, and from here comes the adjective versatile video coding. A particular note is for that open source implementation of the encoder from Fraunhofer HHI called VVC Hank. Then there are demonstration and software decoder, and also there is one encoder product by Bitmoving based on that VVC Hank. The main tools of this VVC are the frame partitioning. They have larger coding unit, 128 by 128, and then VVC has enriched the frame partitioning by introducing the binary tree and the ternary tree that further split the square blocks into rectangles. The intra-prediction improvement, intra means exploiting the redundancy within the same picture, and they have now 65 new directions plus DC and the planar. For the inter-prediction, that means exploit the redundancy between pictures, there are a lot of tools decoder side with the idea to don't send the motion vector but to infer them decoder side. And also there are a lot of tools for the motion compensation improvement. And there are new transforms, for example, the non-separable secondary transform to better handle the oblique patterns in the intra. In the intra-prediction, and also in the in-loop filter, they are using also the bilateral filter that is able to denoise the flat areas while preserving the edges. This table shows for each new version of the reference software of the VVC, the increasing in the coding gain, because meeting cycle after meeting cycle, they add new tools to the reference software, and of course the gains get better and better. The problem is that the side effect is that the encoder and decoder runtime get worse and worse. It's a bit better at the end because they did a bit of optimization. Also, this table shows the difference in gain between the UHD and the HD. For the new codec, is easier to get higher gain for higher resolutions. And I think that's because of a large coding unit of, in this case, 128 by 128. So there is a 5% difference between UHD and the HD. This is the graph from the VVC verification test. In the x-axis, there is the bitrate, and the y-axis, there is the mean opinion square. And as you can see, the blue curve is the HEVC. The orange one is the VVC, and the other one is that from VVC Anc. There is 43% gain improvement for VVC over HEVC, and even on 49 gain for the VVC Anc over the HEVC. So what comes after VVC? There is the version 2 is planned, and there is a range extension called operational range extension. The target is the high bit rate, in this case 12 or 16. They are meant for contribution instead of distributions. And there is also the versatile same message, this supplemental enhanced information that are metadata needed for the decoder to decode in the right way the picture. Historically, they were in the same specification of the standard. Now they put in a separate specification, and that's because now they can be referenced by other codec, for example, from AVC or from HEVC. There are two long-term activities ongoing, two exploration activities. One is based on neural network, so neural network-based video coding. They are working inside VVC, and in particular, they are working in the loop filter, and they have a codec gain of 10% improvement over VVC. They are working also on super resolution and also on the intra-coding. In the intra-coding, the gain over VVC is 3%. And also there is another activity called enhanced compression model that is working on traditional algorithms. That means everything but not machine learning based. They got 15% bitrate reduction compared to VVC. That is a very good number. But now it's getting harder and harder to get that 50% improvement that they need to deploy a new standard, because probably they are reaching the knee of the curve. And there is also 4 times the encoder and decoder runtime. This picture shows the patent issue. I mean, it's still difficult to evaluate the cost of the licensing for HEVC, because there are 3 patent pools: MPEG LA, HEVC Advanced, and Velius Media. And there are also many companies that manage their own EP. They manage their EP by their own. And this situation has slowed down the adoption of the HEVC, and now HEVC is challenged by other companies or groups that promise better performance with royalty-free usage. By the way, there is this media coding industry forum that made the effort to do a patent pool fostering at the end of 2020. They got a significant number of participants, 50 participants, and as you can see, there are also important players. And the goal was to come with a single patent pool for VVC. They were not able to come with a single recommendation, but they found support from MPEG LA and HEVC Advanced. So we will see what will happen around VVC. This is the other standard organization working on video. The Alliance for Open Media with their codec called AV1. AV1 is made by a combination from VP9 from Google, Dala, Mozilla, and Tor from Cisco. There are important players also in AV1, and it's a royalty-free codec. But as I said, royalty-free should be, these two words should be forbidden in the video world, because I mean, patent holders are strange creatures that live in the dark. And then when the standard is well used, they spring up like mushroom and say, "Oh, I have a patent." And we know now that Sysvel, the company name Sysvel, hold a patent pool with 1,400 patents for around AV1. So I think we shouldn't use royalty-free anymore, but something like its royalty maybe. And they have also planned for the next generation called AV2. It doesn't work anymore, the remote control. We'll go back. Okay. Okay. Yes. I'm sorry for that. So as you can see, there are services that are already using AV1, YouTube and Netflix. There are also implementation into the TV set provided by Samsung and LG, and a particular note for the open source software encoder by Intel. The third standard organization is called MPI. And there are a lot of groups working on different aspects, different topics. I won't go through all of them, of course. They've already published 4 standards. But because today we're speaking about video, my focus will be on the AI-enhanced video coding, the video group inside MPI. They are working on the EVC, the essential video coding, in particular the open source version provided by Samsung. And they are working on mainly on 2 tools, the intra prediction enhancement, and they got 5% improvement. And super resolution, they got another 5% improvement using tools AI-based. And this is a research from Rethink TV that shows a forecast on the video codec adoption. In the x-axis, there is a time. They span from 2020 to 2030. And on the y-axis, there is a percentage of workload that actually is using that. See the black curve, the AVC is still predominant, but there is a steady reduction in the next 10 years. The yellow one is HEVC. There is a steady, slow but steady increasing for this codec. The same, similar with AV1, the blue curve. For the red one, VVC is it's early for a forecast, I think. And also, if you notice, there is the orange one. I mean, MPEG-2 is still alive. So what is happening in EBU about video? There is this umbrella group called the Video System Workflow, led by Simon. The main activities, the main focus is on measurement of professional video monitors, especially for HDR. And they are updating the EBU Tech 3325, and that will help members to do the measurement on their own studio monitor. Then there is the HDR implementation task force led by Andrew with the idea of sharing experiences and best practices around HDR. There is the EBU guidance on the non-standard exposure ratio led by Kayatri, because here the focus is on especially on the social media. They have a ratio that is different from the broadcaster one. It should be managed in some way. Then the UHD TV strategy support group led by Carl. That has produced the guidance for the UHD material, both for live and file-based production contribution. And then I'm leading the video evaluation group. It's a cross group for the video quality assessment for both objective and subjective evaluation, looking for an objective metric that is more correlated with the subjective evaluations. Our main focus now in the testing of the mezzanine codec, that are codec meant for the IP world. We are working on the automation, in particular Blackmagic HyperDeck automation, and also automation of the objective matrix and the automatic generation of the report in PDF with the graphs, statistic, and objective matrix. So please join the EBU video group, and also please have a look on the RAI survey on the European project AI for Media. That it's about artificial intelligence applied to media. We did a lot of research to build this survey, so I think it's interesting to read what we have found. So please join and survey. And also, I think it's okay the other way around, survey and join. And that's all from my side.
Thank you, Roberto.
You're welcome.